Example 2. A closely wound circular coil of diameter of 10 cm has 500 turns and carry a current of 2.5 ampere. Determine the magnitude of the magnetic field at the center of the coil. Okay, so dia nak suruh cari magnitude saja, jadi tak perlu guna direction. Okay, how to determine this? Dia adalah circular coil. So kita ambil formula circular coil. B is equal to mu naught Ni over 2R. Okay, so 4 pi times 10 to the power of negative 7 times with 500 turns, okay, times with current 2.5, and then divided by 2R. 2 times R is 5 times 10 to the power of negative 2. Ini diameter. Okay, D sama dengan 10 cm. Kalau R dia adalah D per 2. Sebenarnya kalau ikutkan 2 darab R sama dengan diameter lah kan. Okay, so we will get answer 1.57 times 10 to the power of negative 2 Tesla. Okay, alright, so next is example 3. We have question A. 200 turns of solenoid of length 40 cm and resistance 16 ohm is connected to 20 volt supply. Find the magnetic flux density of the midpoint of the axis of the solenoid. Okay, midpoint, so kita guna formula midpoint lah. So B at the midpoint for the solenoid is equal to mu naught Ni over L. Tapi soalan ni dia bagi kita length, dia bagi kita radius pula, resistance and V. Jadi dekat sini dia tak bagi I. Jadi apa relation I dengan V and R? So adalah Ohm's law lah. V is equal to IR. So I is equal to V over R. Okay, so kita boleh ubah formula ni akan jadi mu naught and V over LR. Okay, so substitute the value. Mu naught is 4 pi times 10 to the power of negative 7, and then N is 2000, and then V is 20 volt divided by, okay, length is 40 cm. 40 times 10 to the power of negative 2, and then radius is 16 ohm. Okay, so the answer for B, magnetic flux density at the midpoint of the axis of the solenoid is 7.85 times 10 to the power of negative 3 Tesla. Okay, so B, okay, we have a solenoid of length 1.5 meter and 2.6 cm in diameter, carry a current of 18 ampere. The magnetic field inside the solenoid is 2.3 milli-Tesla. Calculate the length of the wire forming the solenoid. So kita ada beza dekat sini. Length of the wire to forming solenoid adalah L besar, and then length when dia jadi solenoid adalah L yang ni. So tak sama Okay, so formula is B is equal to mu naught Ni over L. Okay, untuk dapatkan length of the wire forming, kita nak dapatkan muka dia tu. So kita kena cari dulu berapa banyak dia punya turns. Sebab awak nak darab dengan berapa banyak dia punya circumference. You dapat satu circumference, you kali dengan berapa turns untuk dapatkan dia punya length of the wire forming the solenoid. So first kali kita cari number of turns dululah. So B is 2.3 times 10 to the power of negative 3 milli-Tesla kan. Okay, mu naught dia 4 pi times 10 to the power of negative 7, and then N number of turns nak cari, and then I 18 ampere, and then divided by the length is 1.5 meter. Okay, so we get 152 turns. Kalau ikutkan dia ada point, contoh point 1.52, is it? So dia equivalent to 152, bukan 153, 152. Kalau 152.99 pun you ambil 152. Kita ambil nombor bulat kat depan, okay? Kita ambil nombor bulat ni. Alright, then after you get the number of turns, okay, dah dapat number of turns, kita kena cari dia punya circumference lah. Means that satu bulatan ni berapa nilai dia. Maksud circumference adalah 2 pi r. Okay, so 2 times with pi times with radius of the sebab dia bagi diameter 2.6, jadi radius adalah divide by 2, 1.3 times 10 to the power of negative 2. Okay, so we get 1.3 exponent negative 2 times with 2 pi. So you will get 8.17 times 10 to the power of negative 2 meter. Okay, dah dia punya circumference. So dah dapatkan length of the solenoid, length of the wire forming the solenoid is L equal to number of turns times dengan circumference. Okay, okay. Alright, so number of turns is 152 times with 8.17 times 10 to the power of negative 2. Okay, so berapa yang kita akan dapat? 8.17 exponent negative 2 times with 152. So you will get 12.41, 12.42 lah, 42 meter. Okay.